I am Mabel J. Shasin, and today we will be talking about the overlearning and learning motor skills. Researchers historically have investigated the relationship between the amount of practice and the achievement of specific performance goals within the topic of overlearning. Overlearning is the continuation of practice beyond the amount needed to achieve a certain performance criterion. It is implemented by teacher, coach, or therapist by establishing a specific performance criterion, such as specific accuracy average for throwing a certain number of balls at a target. The teacher then requires students to achieve that performance criterion during class, record the number of trials it took for the student to reach that goal, and then require a specified number of additional practice trials to implement an overlearning practice condition. From a theoretical perspective, the assigning of extra practice has merit. According to a motor program-based motor learning theory, extra practice helps strengthen the generalized motor program and response schema for the skill a person is learning, so that the person can call it into action more readily when necessary. From a dynamical systems theory perspective, extra practice is a means by which a learner increases the stability of the coordination and control characteristics in the performance of the skills. Driscoll, Willis, and Cooper of 1992 reviewed and analyzed 15 research studies that investigated several hypotheses related to overlearning. The first notable point about this review is that the issue of overlearning has not generated a great deal of research over the years. The 15 studies covered research articles published from 1929 to 1982. However, these studies involve almost 4,000 subjects, which gives us a good basis for discerning the influence of overlearning on skill acquisition and how various factors influence overlearning. The results of this review indicated that for motor skill learning, overlearning has a positive influence on retention performance. And when extra practice of 50 to 200% was analyzed, the higher percentages resulted in relatively proportionate higher retention test performance. Although the Driscoll et al. Of 1992 review provides a comprehensive overview of overlearning as it relates to skill acquisition, it does not evaluate effects to related specific types of motor skills, because motor learning research has shown that certain types of skills demonstrates some distinct characteristics with regards to overlearning. We will consider 3 examples in this section. First, the overlearning strategy for learning procedural skills. Second is the overlearning strategy for learning dynamic balance skills. And the third is the overlearning strategy in a physical education class. The overlearning strategy for learning procedural skills. Procedural skills constitute one type of motor skill particularly well suited to deriving benefits from an overlearning practice strategy. A procedural skill is an interesting combination of cognitive and motor components. It typically requires a person to perform a series of movements that individually are relatively easy to execute. However, to accomplish the total task, the performer must know which movements to make and in what order. These types of skills are especially common in occupational, industrial, and military settings. For example, people perform procedural skills when their jobs requires them to put together the components of a circuit board for a computer or type from a written text. The common problem with procedural skills is that people tend to forget what to do to carry out the entire procedure. This is particularly characteristic of procedural skills that they do not perform routinely every day. Next is the overlearning strategy for learning dynamic balance skills. In an experiment that involved learning a skill that has less of a cognitive component than the gun assembly or disassembly skill, Melnick of 1971 investigated the use of overlearning for a dynamic balance skills. This experiment continues to be the only one reported in the research literature that involves the overlearning of dynamic balance skills. In addition to addressing the question of whether practice beyond the amount the learner needed to achieve a performance criterion was beneficial, Melnick asked whether there was an optimal amount of extra practice. In this experiment, people practiced balancing a stabilometer until they were able to achieve a performance criterion of being on a balance 28 out of 50 seconds. After achieving this criterion, each group was required to perform further trials in one of the following amounts: 0% or none, 50%, 100%, or 200% of the initial numbers of trials to practice. Then all participants perform a retention test twice, 1 week, and then 1 month after practice. The results showed that all amounts of extra practice were beneficial. This means that all the groups that engage in extra practice beyond what they needed to achieve the performance criterion performed better on the retention test. More interesting, however, was the result that there was a point of diminishing returns for the amount of retention performance benefit in relation to the amount of extra practice. This effect can be seen in the results when the group that had 50% additional practice did as well on the retention test as the groups that had 100% and 200% extra practice. So, although additional practice was beneficial, increasing the amount of additional practice beyond the 50% amount was not proportionally more beneficial to retention performance. Last is the overlearning strategy in a physical education class. Researchers also have demonstrated the presence of the diminishing returns phenomenon for learning skills in physical education class. A good example of this is an experiment by Goldberger and Gurney of 1990. In a unit of instruction, 5th grade boys and girls practiced several football skills. The goal of this unit was to help students improve their performance of these skills. To simplify matters, we will look only at the two-step football punt. One group practiced these skills according to a teacher-rotated format in which the teacher divided the class into 5 subgroups and assigned each to one of 5 stations where they practiced a specified skill for 5 minutes. At the end of every 5 minutes, students rotated to a new station. Another group of students practiced according to a learner-rotated format. They received index cards describing what they needed to do at each station and then were told to use their 25 minutes efficiently to practice each skill. Everyone practiced like this for 2 class periods on 2 days. The next week, the student performed the skills in a test. The results showed that the 2 groups differed in terms of the number of practice trials for these skills but not in test performance. The teacher-rotated format group actually practiced the skills an average of 4 trials than the learner-rotated format group. Students in the learner-rotated format group performed from 0 to 67 trials, whereas students in the teacher-rotated group performed from 0 to 87 trials. But there was no difference between the groups in the amount of improvement in their punting performance scores. Additional amount of practice induced by the teacher-rotated format did not yield an additional skill performance improvement benefit on the retention test. Thus, given the time constraint of the unit of instruction, the learner-rotated format was superior because it provided more efficient use of the available practice time. Thank you for listening. Next reporter, please.